Good afternoon, everyone. Today, I am going to present my project, the mystery number name. The target audience is primary six students. For many primary six students, algebra is a black box of abstract rules. My project opens that box. By transforming algebra into detective investigation, we turn solving for X into an evidence-based inquiry. This module is grounded in the EDB's primary mathematics curriculum, bridging the gap between primary 5 foundations and primary 6 problem solving. So why did I choose this topic? In primary 6, students face their most significant mathematical hurdle, the transition from arithmetic to algebra. We see two major challenges here. First, the action button misconception. Most students view the equal sign as the signal to calculate the answer rather than a symbol of equivalence. Second, the challenge of abstractions. The equations like 3x plus 4 equals to 16 are often taught through rote memorization, telling students to move the number and change the sign, without them understanding why. The mystery number lamp solves this by replacing blind memorization with visual logical proof. So before our detectives can solve higher level cases, they need some basic training. As outlined in units, learning units 5A1 and 5A2, students must master using letters for numbers and the logic of balance. My detective briefing part is used to activate previous knowledge of inverse operations. We ensure students remember that addition and thus subtraction before we ask them to solve the complex multi-step problems of P6. So you can see that here are some notes for them before the training. Now let's enter the lab. The heart of this module is the exploration phase, which I have designed it as a three-mission scaffolding ladder. This ensures students consolidate each concept before moving on to the next. So we can see the field manual. There are three missions. Mission 1 is the law of equilibrium. It consolidates the 5A2 logic. Students use simple constants to see that if they don't perform the same action on both sides, the scale tilts. For the mission 2 is the variable mystery. Here we introduce the X jar. Students must isolate the unknown using a single inverse operation. This bridges the gap between physical objects and algebraic symbols. So for the mission 3 is a 6A1 mastery level. Students tackle multi-steps equations like AX plus B equals to C. By this stage, the scaffolding has prepared them to decide which operation to undo first. They aren't just memorizing steps, they are visualizing the weight of the math. At the end is the most innovative part of the lab, our AI lab assistant. In class of 30, a teacher cannot be everywhere. My AI acts as a Socratic tutor, providing personalized scaffolding. It doesn't give answers. It provides hints based on the student's specific roadblock. So you can put your questions in the Gemini AI chat box. For a 6A1 problem like 3x minus 5 equals to 10, a student might not know where to start. The AI might ask, to find x, should we first add back the 5 coins we lost or try to split the jars? This is adaptive scaffolding. If a student makes an error, the AI provides an immediate feedback loop saying the scale is tilted. Remember the golden rule. Whatever you do to the left, you must do to the right. This technology promotes metacognition. By prompting students to explain their logic, the AI ensures that they aren't just clicking buttons, but are actually internalizing the algebraic mirror rule required by the EDB 681 guidelines. It transforms the website from a static tool into a dynamic, responsive mentor. So the last part is a task. Every investigation ends with a report. So there are three parts of the task. It should be a form. You should fulfill the Google form and the solve it game challenges. They try to use the game mode to find some answers at level 3. They need to have a challenge it. Students submit their findings through this embedded form. This is our formal assessment. I ask them to define their unknowns and verify their answers through substitution. This mirrors the curriculum's emphasis on checking the solution, ensuring the detective's case is truly closed. After they finish these 3 tasks, they need to submit their answers through this mission completion. It's also a Google form to put their findings into this Google form. To conclude, the Mystery Number Lab is a pedagogical bridge. By ensuring our tech in EDB 5A and 6A standards and utilizing AI mentorship, we create a learning environment where algebra is intuitive and accessible. We aren't just teaching students to find X. We are teaching them to think like logical investigators. That's the end of my presentation. Thank you.